Okay, so this is a video of me going over the quiz that we took over sections 9.1 through 9.4. So number one says, is AB a tangent to circle C? Show why or why not. So the first thing that I have to know is that this is a radius, and we think that this is a tangent. And if it is a tangent, sorry about that, if it is a tangent, then those two things form a right angle. So the question is really here, does that form a right angle? So when we look at this problem, we're going to use Pythagorean's theorem to determine if that's true. Now I notice that I have a side here of the triangle and a side here. What I need also is the hypotenuse so that I could do a squared plus b squared and compare it to c squared, because if a squared plus b squared equals c squared, then this is a right triangle and that angle at A would be a right angle. So I notice that I don't have all of that hypotenuse. This is the hypotenuse. It's opposite the right angle. So this right here is a radius, and so is this. So that means I can repeat that 4 right there. So now I can see if this is a right triangle, and thus if the angle at A is a right angle. So I'm going to do 4 squared plus 12 squared. And what I want to see is it equal to 14 squared? And that's because this right here is 14, because 4 plus 10 is 14. So this is 16 plus 144. And again, we're asking ourselves the question, is that going to be equal to c squared? So this is 196 here. When we add 16 to 144, we get 140. And over here we had 196. So these are not equal. Thus, this angle right here is not a right angle. So when it asks us if AB is a tangent, the answer is no, because A is not a right angle. Okay, now over here for number 2, it says find EF. Now what I notice is that we have two tangents. This is a tangent and this is a tangent because it touches a circle at one point. Two tangents coming from the same point. That means these two tangents are congruent. So we're going to set these two equations equal to each other. So that's 2x plus 4 equals 3x minus 5. So we're going to subtract 2x from both sides. That gives us an x over here. And we're going to add the 5 to both sides. So that gives us a 9 over here. Now we're not done because the problem actually tells us to find EF. So we have to plug that back in. So we're going to do 3 times 9 minus 5. That's 27 minus 5. So our answer here is 22. So EF is equal to 22. So on number 3, it says FH is 20 plus 2x. So I'm going to go ahead and mark that. FH is 20 plus 2x. And then it says that BD is x plus 25. So I'm going to put x plus 25 over here. Now, I notice a couple things when I look at this drawing. I notice that, well, first of all, I noticed that something was missing on the drawing that should have been there. There should have been some right angles there, y'all. So if those right angles are not there, then we really couldn't have solved the problem, but we're going to put them in there now. So we should see that this is congruent to this because there were right angles there. And I omitted the right angles on the drawing when I drew it for this problem. So hopefully y'all set it up right. So these two chords are congruent because they are the same distance from the center. That's what these tick marks right here tell us. And because they're right angles to those lines that are from the center, which means they're perpendicular. So we're going to set these two equations equal to each other. 20 plus 2x equals x plus 25. We're going to subtract x from both sides, so that gives us x over here. We're going to subtract 20 from both sides, so that gives us 5 here. Now it tells us to find BD. So when it says to find BD, we are going to plug that 5 back into the equation for BD. And that equation was x plus 25, so it's going to be 5 plus 25, and that's equal to 30. So BD is equal to 30. And as I've said in the past, you can check these. So again, if we put the 5 on the other side, 20 plus 2 times 5, that would be 20 plus 10, and that is also 30. So a great way to check the answer. So now our property here with number 4, what I taught my kids was part times part equals part times part. And we're talking about parts of the same chord. So here we're going to take the 7 and multiply it times the 2x plus 2, and we're going to multiply the 2x times the 8. So that's what we're going to do here. So I'm going to say 7 times 2x plus 2, and that equals 8 times 2x. When I do that, I get 14x plus 14 is equal to 16x. Going to subtract 14x from both sides. That gives me 14 here is equal to 2x. Going to divide both sides by 2. So x is equal to 7. Here again, it tells us to find TG. So we have to plug that back in. And the equation for TG is 2x. So that's equal to 2x. So that means it's 2 times 7. So that's 14. Now remember again, we can solve this. And make sure, test it to make sure our answer is right. So what we would have done up here if we were checking this is we would have done 8 times 14. And what we want to see is that equal to, and I said 8 because the 8 here, and this is 2 times 7, which is 14. And then down here, it's going to be 2 times 7 plus 2. And 2 times 7 is 14 plus 2 is 16. So the question we're asking ourselves is, 8 times 14 the same as 7 times 16? And the answer is yes, both of those are 112. So now we're on number 5. And on number 5, what I taught my kids was we're going to do outside times the whole. We're going to set that equal to the outside times the whole. So our outside here is 6, our whole is 6 plus 8, so that's 6 times 6 plus 8, and that's equal to the outside here, which is 7, and our whole is going to be 7 plus x. Okay, so this is going to be 6 times 14, and this is going to be 49 plus 7x. 6 times 14 is 84. Equals 49 plus 7x. Going to subtract the 49 from both sides. That gives us 35 equals 7x. So here again, x is equal to 5. So that's our answer. Now, what we want to do to make sure that this answer is correct is plug it back in. So we know up here we had that 6 times 14 was 84. So down here we're going to see what is 7. And this is now our 5, right? 7 times 12. And 7 times 12 is also 84. So again, we can check these problems to see if they're correct. Same process for number 6 as it was with number 5. We just have a little bit different problems here. So again, we got the outside times the whole. So that would be 7 times 7 plus 11x. And again, outside times the whole. So that's going to be equal to 6 times 6 plus 15x. So now 7 times 7 is 49, and this is going to be 77x. Sorry, I don't know why I put an equal sign there. Plus 77x is equal to 36 plus 15 times 6 is 90x. Going to subtract 36 from 49. That's going to give me 13, and I'm going to subtract 77 from 90. That's also going to give me 13. So my x here is equal to 1. Again, the question asked me to find AC, so I have to plug that back in. So this time, when I plug it back in, this is going to be 15 times 1, so that's 15, and AC is just a length. So all I have to do here to find AC is add those two parts together. So I'm going to add 15 to 6. Sorry, that should be a plus there, y'all. 15 plus 6, and that's 21. So AC was 21. Okay, so let's work the last two problems. Now 7 and 8 are different from 5 and 6 because 7 and 8 have a tangent and a secant. So when we do these, we're going to do tangent squared equals outside times the whole. Okay, so our tangent is here. So we're going to take that 30 and we're going to square it. And I kind of like to do it there. And then we're going to do our outside again times our whole. So our outside this time is 18 and our whole is 18 plus x. So 30 squared is 900. And this is going to be 18 times 18, which is 324, plus 18x. We're going to subtract the 324 from both sides. That's going to give us 576 is equal to 18x. And then we're going to plug that, we're going to divide both sides by 18, so x is equal to 32. Now here again, we can check our answer. So we're going to put that 32 right here, so we can check our answer. Now we know that 300 squared is 900. Now what we want to see is 18 times 18 plus 32, 900. So this is actually 50. The whole length. So is 18 times 50? The question is 18 times 50, is that 900? And the answer is yes, it is. So once again, we can check our answer. All right, so number 11 is outside times whole. So again, is a tangent. This is our tangent. So we're going to square this, and then we're going to multiply that. Then we're going to set that equal to the outside times the whole. So the first thing I have to do is x plus 6 squared and set that equal to the outside, which is x, times the whole, which is x plus 16. Now you guys may or may not remember this, but doing this process for this right here, we're going to put this twice. Now most of you don't remember the pattern that I taught, so I'm going to go ahead and put it twice, and I'm just going to FOIL it. Over here, I'm going to do the similar thing. I'm just going to multiply x times both of those things. So when I multiply x times x here, I get x squared. When I do the outside, I get 6x. When I do the inside, I get 6x. When I multiply 6 times 6, I get 36. Over here, when I multiply x times x, I get x squared. When I multiply x times 16, I get 16x, sorry. 16x, okay. Now these are like terms, so I'm going to combine them. So I get x squared plus 12x plus 36 equals x squared plus 16x. Now you should notice at this point that I have x squareds on both sides of the equal sign, so I don't know why it did that, but so I can cancel these out. And I'm left with my 12x plus 36 equals 16x. So I'm going to go ahead and subtract the 12x from both sides. So that means 36 is equal to 4x, and we're going to divide both sides by 4, so our x is going to be equal to 9. Once again, we're going to put that value into the equation just to check it. So this is going to be 9 plus 6 squared, so that's going to be 15 squared. That I happen to know is 225. And then over here, we're going to put the 9 again. So that's going to be 9 again, and 9 plus 16 is 25, so that's 9 times 25. That also is 225. So if these two answers are the same, then we've checked it out and we got the correct answer.